back to my machine shop. I have another project I'd like to share with you. Today we're going to do this project on my Bridgeport milling machine. What I have here is a new harmonic balancer that needs to be fitted to this Duramax crankshaft. To do this, I have to cut a keyway to the snout of this crankshaft. I'm going to show you a few tips, procedures I go through to get this lined up that might even help you with some future projects.
So before we get started, I need to figure out the size of this keyway. There's multiple methods of doing this. You can go about it with your feeler gauges. You can go about it with a known dimensioned piece and your feeler gauges. In this case, this is smaller than the slot and it fits in there. And I can get a 9th thou feeler gauge in there. I can measure the two together to get my number. I can measure this on its own and add the thickness of the feeler gauge. In both circumstances, I get the same number. Another way to do this is with a gauge block set. You can come in here, stack multiple different gauge blocks to get different assemblies. Ring them together and then fit them in the keyway. And this way here I can find out which one fits the best. Now that this is done and I know what size my keyway is, we can jot that down and pick the proper end mill for the snout. I get a measurement of 196 thou. So when I set up my machine, I'm going to go in with a 3/16 end mill, which is 0.187, and that way there I'll have to do a couple passes to get to the proper width. Cut. So here's the crank set up on the mill. I've already dialed this thing all in. It's true, it's where it's supposed to be. I'm going to show you a few little things I've done. First off, I've set the snout in my vise and I've had to shim the back of the crank up. To know if I'm level or not, I just did a quick, simple gauge fixture like this. I ran this across, found the highest point of this journal, called that 0, come across farther down to another journal, and then I shimmed this up until this said 0 as well. In this case, it's telling me I'm 1 thou out. That's over 10 inches. I'm only machining an inch. It'll be a 1/10 difference. I then stuck the same dial on my quill and I ran it up and down here till I found my high point, moved my table over, I came down here and I did the same thing, and that told me that my alignment was true to my machine. So now this is how I found the center of my crank. Again, I've already pre-found all the center lines everywhere I need to cut just to save time for these videos. I stuck my test dial on my spindle, pull it forth to approximately 0, and then I find my 0. And I rotate around here to find the other side. If there was a difference, we would correct that difference. In this case, I am 0, 0. I am in the center of my vice jaws right now. I then reached over and I pushed 0 on my readout. Now I want to make sure that my pin is in the right location. So I move my table over. And I set my dial on this pin. And then I find out that I am in the center of my pin, or I should say my pin is in the center. Now, like I said, I've already aligned this up. It took a little bit of effort. Had this showed me that I was out, I would have to loosen my setup and index my crank a little bit, whatever way it would have to go. In this case, we're already zeroed. Everything's good to go. Okay, so first thing I'm going to do, I'm going to remove the bulk of this pin off. To do this, I'm just going to use my 7/16 solid carbide end mill, and we're just going to nub it off, and it's going to be less work for my little 3/16 end mill. Alright, now that that's done, we can put in my 3/16 end mill. Since my end mill is smaller than the slot I'm cutting, I'm going to go ahead and use a 4-flute end mill. For this, I'm going to change the speed of my machine. This speed is going to burn this end mill up. These cranks are kind of hard, and I've burnt up a few end mills in my day. So. Set till I touch. We'll set that at 0. I'll give a 20 thou increment. A little bit of cutting oil. This is going to be where I stop. I'm going to set 0 on my readout, my x-axis. Increment my depth of cut again. So far, I've got 110 thou depth, and I just want to take a measurement, see where I'm standing. For this, I'm going to use a little depth gauge here. We'll set this at 0. I have about 15 thou more to go. So we'll increment my thickness of the keyway, plus around maybe 5 thou or so, just to ensure that it fits. Now I'm going to measure the thickness of the slot. Again, I'm going to use my gauge blocks for this. Stacked together. Take a mic measurement. They're telling me that I've cut to 188 thou. So using my readout, 4 thou on my y-axis. Now I've moved my table in a manner that I will be klein milling. That will give me a better finish. Before I go ahead and increment to the next size, I'm going to take a measurement, make sure I only remove 4 thou. That feels pretty good to me. So now I'll increment my y-axis. The other direction. Approximately 4 thou, and I will feed my table back out. Now I'll take a measurement of the keyway I've machined. That's a little too large. And that's a perfect fit. I am now at point 195 and 8/10. So that's pretty close. That'll make my keyway be nice and snug. If it's too tight, I can run in here with a little file just to make it fit better. I think it's going to be good to go.
So now we've got the keyway cut in our crankshaft. I actually have to make a key as well. So what I have is a piece of key stock. It's a 1/4 inch by 1/4 inch. I need 5 mil by 5 mil, which is 0.196 thousandths. I'm set up, I'm dialed up, and now I'm going to commence cutting.
So I come in, I I touch, I'm going to call that 0. I'm going to take little cuts and remove 30 thou. So I hung this key over the end of the vise just so I could come in here and actually take a measurement of the thickness. So as it stands, we're at 212. Exactly 0.196.
So I milled this key to thickness. I just want to try it in the snout. It's a nice snug fit. I'm happy with that. Now I have to mill this thickness down to the correct size, because this is still a 1/4 inch thick by 5 mil. We want 5 mil by 5 mil. So I'm going to put this back in my vise. I'm going to dial it up, and then we're going to mill that to thickness as well.
Again, I'm going to leave a little bit hanging out of the end here so I have something to measure. Dial up 0 now. Take a measurement now. This puts me almost exactly where I want to be. Getting about 0.197. do is trim the ends off.
Here's our milled key. We're going to put this into our key seat. Snug. It's the correct length. It fits either way. This is a nice square key. We'll do a little bit of deburring, make it look good, and that's the finished product.